So what is the main idea between the cyber and physical system? Means you can see this, the left physical power world, the physical world, energy system, manufacturing, transportation, which is strongly interacting with the physical, that is a cyber system, computation, communication, and control. Again, this virtual world is again depends on the physical system. So this is the main idea. If you can understand this, you can apply for any type of system: energy, manufacturing, transportation, agriculture, or water, oil and gas. So any type of systems that fully depend on the this cyber systems. So that is a core idea in a cyber physical system. So the next one is a cyber contingency and the power systems. So we can see this, the left side, the power system, and then a power grid. So as you hope, I hope that you can see in this the one line diagram. And here only the energy flow in the power grid. And right hand side, it is the energy management system, usually the cyber system. Here only energy flow. So what will happen? What is the main function of this system is? So the cyber system will monitor the physical power grid. So that is the measuring of the signal. So using the PMU or SCADA, you can get the status of your electrical power grid, and the signal is transmitted from power grid to cyber system. Now, after calculating the control signal, again from the signal will be transferred from control center to the electrical power grid. So that is called as control signal. So the traditional point of view, we will focus only on the electrical power systems. But a modern side, we have to focus on cyber system also. So then only we can make a whole system as a stable system. So that's what the challenge is, how to evaluate the degree cyber contingency influence the physical power system. So the meaning is, if any problem occurs on it, suppose if any problem occurs on the cyber system, how it will affect the physical system. So that is the main challenge. So we have to be considered in the cyber physical system. So interdependent and interaction. So the arrow mark clearly indicates, you can see this is the bidirectional arrow. So the power grid is fully monitored by the closed loop control, that is cyber system. Again, the cyber system fully depend on the accurate data from the power grid. Suppose if there is any problem in this, the cyber side failure will severely impact the performance of the power system. You see this already, the 14th of August in 2003, the blackout occurred. And another one, the problem because of cyber system occurred in Italy. That is a communication congestion is a cyber side failure. And the automation generation control malfunction in China. So that also happened because of the from the cyber side. So not only because of the fault, so because of the problem in the cyber side, it will affect the performance of the electrical power system and leads to the blackout condition. So this is called as the interdependency and interaction between the two systems. So the next one is a interaction mechanism. So you can see this, the cyber system in right hand side is represented in the blue color. So I told that the blue color represents the data flow, and the cyber system fully monitoring your electrical power systems. So this shows a continuous monitoring and control as well as a interaction mechanism. If any problem occur in cyber, it will affect your power grid, and if any problem in the power grid, it will affect your cyber. So that is called as the interaction mechanism in cyber physical power system. So the next one is what are the challenges in a cyber contingency? So the disturbance on the cyber board, that is a cyber contingency. So the cyber contingency in a cyber that a smart grid result in the risk on the power system. So that is the major problem in the current power systems. And we need to have a general modeling of cyber physical systems. So we need to model not only the electrical power systems. So we will model the power system using the algebraic equations, the differential algebraic equations. So, but nowadays this is not suitable for modeling of the current power systems, because of power systems is integrated with a cyber system also. So we need a general model to combine both power and cyber. So the next one is a modeling, how to model. The modeling assessment is very, very important for the nowadays research areas. So you can see this. So the first one, cyber system. So it involves the satellite timing, that is GPS, substation 1, substation 2, and a remote measurement and control dispatch center. So this is the one part of our cyber system modeling. And physical system modeling, as usual, generation, transmission, transformation, and then distribution and the user. So you can see this, the both the systems to be combined, Presently, we are focusing on in this only power system analysis. So you have studied the power system analysis, Newton-Raphson method and the Gauss-Seidel method, and then N-1 reliability analysis. So, but nowadays we need to move from the conventional method to a cyber physical analysis. So in addition to the power flow analysis, we need to perform the cyber side modeling also. So that is called as cyber physical modeling. That means information and the energy flow should be merged or combined or coordinated. So that is called as information energy flow. So hereafter we cannot only talk about the energy flow in the electrical power system. So we need to consider both the energy flow as well as the information, that is data flow in the electrical power systems. That's what it is represented as expanding the traditional method to the cyber side. We have to move towards the cyber physical analysis from traditional analysis. So you can see this cyber physical analysis from power system analysis to cyber physical analysis. So physical power system, that is the power system analysis, what normally what we will do, we will perform the network topology, network analysis, and what is the property of that model, and then the system state is only power flow, very very important. Now we have to move from conventional power system to cyber physical modeling. So by doing this, we can expand the current power system modeling to cyber physical power system, and for this we need to have a unified model for to assess the cyber contingency. So the main question is how we are moving from physical to cyber physical. So that is the challenging task in the nowadays, and more advanced methods are also available for physical to cyber physical power system analysis. So you can see this example cyber physical power system model, how it look like. So the first one is a matured one, and the second one is a challenging task. The first one is a matured field, is a power grid model and a node branch equivalent model. So this is taken from the traditional power system modeling. So in the traditional power system modeling, we have the power system model and we'll perform the load flow analysis. But the modern challenge is information flow oriented network model. So in addition to the power system energy flow analysis, we need to perform the information flow analysis. So that is the challenging task in the existing power systems. So we need to map the energy distribution, electrical property, and the device connections. So these two systems should be connected, and we have a common cyber physical power systems. So I'll show the model. So you can see this a power system and a cyber system for a secondary voltage control method. So the left hand side, the power system, it shows the one line diagram, and then the right hand side you see this the cyber model for this 39 bus New England system. So the 39 bus New England system is completely divided into the areas. So you can see this, there are 6 areas, A, B, C, D, E, F, 6 areas. And then one of the area which is connected with the cyber model of the centralized, that means a coordinated secondary voltage control. So now what we are doing, we are taking the data. So this is the data taping points. So these data taping points are taken from the physical system, and then it is forwarded to that the next stage, local data communication or compilation, and then move to the centralized data. Again, after calculating the control signal, it will be fed back to the power systems. So parallelly, we can able to view the left hand side represents the power system model, and then right hand side you can see the cyber model, the X-ray model for the physical power systems. So it will continuously monitor the physical power system, and any fault occur in the power system, immediately the action will be activated from the cyber side.
Sir, Raja sir.
Madam, sir, சொல்லுங்க sir.
Sir, if you don't mind, just we'll have a 10 minutes break, sir. Lohandri sir will contact you with this
Okay.
session, sir. Yeah, we'll have
Okay.
a 10 minutes break, sir.
Okay.
Sir will inform you about the next move, sir. Yeah.
Okay.
Uh, Participants, by the meantime, you can fill the attendance link, which has been posted in the chat box. That is the session 9 attendance link for your kind reference. So we'll have a short break. Next moment, that's next session's announcement will be made you soon. We'll have some slight changes in the sessions. After it is been confirmed with Raja Vikram sir, we'll post it here. So be connected. We'll have a short break. Yeah.
Can I able to see my screen?
Yes, sir, it's visible.
Yes, sir, Jagaram, continue, please.
Okay. So after the break, we can move on to the next section, that is cyber attacks and cyber security in a cyber physical power system. So which is very, very important in cyber physical power systems. So cyber attacks. So what mean by cyber attack means it will change the information flow, it will change the data, or it will alter the data. So that is the definition of a cyber attack. So in physical power systems, we know that the importance of data transmission from PMU to control operator. So this cyber attacks plays a critical issue in this cyber physical power systems. So the main issue is very difficult to detect this type of attack. So it will very difficult to detect the attack in the large scale cyber physical power systems. So since the cyber attack plays a major problem, it will leads to the cascading failure across the electrical power grid systems. So if the data is changed or altered, it means the power system operators don't know what to take action or how to control the power grid. So the system will be automatically it will goes to the blackout conditions. So there are a lot of R&D activities. So that's why most of the research and development activities are focusing on cyber security research. So if there is any malfunction occurring on electrical power system, there will be a huge revenue loss in the power sector. So history of cyber attack. So far, what is the history of cyber attack? Where it happened means the first cyber attack was first identified in 1982 in Russia. You can see this. The attack object is gas pipeline control software. So that is the first cyber attack. The type of attack is code manipulation. So that is the code is corrupted or changed by the someone. And what is the resultant of this cyber attack means you can see this the 3 kiloton TNT equivalent explosion. So this is the first cyber attack ever discovered in 1982. So after this 1999 USA 2003 and 2007 8 12 and 15. So there are a lot of cyber attacks happen, and the noted one is 2015 cyber attack in Ukraine. So you know that in 2021 the war started between Ukraine and Russia, but actually the war started in 2015 itself. That war is called as a cyber war. So Russia already attacked the Ukraine since 2015, and 2021 the physical war started between Ukraine and Russia. So because of this cyber war, you can see this there are 225,000 customers are without electrical power for a few hours. So it leads to the large revenue loss for the Ukraine country. So this is the effect of cyber attack on electrical power systems. So and another type of cyber attack happened in Saudi Arabia oil refinery. So we know that Saudi Arabia means that they are having good resources regarding to oil. So every time they are always facing a cyber attack in their oil infrastructure, and then a cyber attack in power utilities in US, and then in India in Tamil Nadu we also faced some cyber attack, that is a Kudangulam power plant, nuclear power plant. So just imagine the cyber attack happened in nuclear power plant means it leads to the loss of a loss surrounded by that power plant. So the global risk report 2024. So the World Economic Forum they have listed out the cyber attack is the fifth attack, fifth risk to be happen in the next 10 years. So the next 10 years, cyber attack going to be play a major role, and it is a fifth risk in the next 10 years. So that's what there is a large importance of cyber security, not only in computer science side, in electrical power systems also, we need to focus on cyber security for electrical power systems. So the next one, security for CPS. So how we can secure our electrical power systems? So there are five strategy. The first one is attack risk modeling and then mitigating the risk. So we have to model the cyber attack and the mitigation measures to be developed for the cyber attack. Second one, attack result monitoring and control algorithm. So your control algorithm should not be attacked by the attacker. So that's what it is called as a attack result monitoring and control algorithm. And third one, defense against the coordinated attack. So the third point is you will not receive the attack from one attacker. So you will receive the attacker from multiple attackers. So you have to defense against the coordinated attacker. And then the fourth one, we have to strengthen the advanced metering infrastructure security and then simulation models. So using this simulation model, we can simulate that. So if cyber attack happen means how it will affect the system, what are the steps to be carried out, we can do in the simulation. So this is the starting point of the cyber attack. You can see this the cyber attack types of cyber attack. So first it will enter into your SCADA, HMI, as well as your field devices, that is sensor actuator. So this is the network through the network the cyber attack will enter. So now it will be enter into your generation, transmission, and distribution, and finally it will make your electrical power systems entirely the blackout conditions. So the starting point is what type of cyber attack is entering into the system, and which place, whether it is a sensor or any network points it is entering into the power system. After that, once it is successfully intruded into the electrical power system, it will leads to the loss of load, or it creates a stability issue in the power systems. So this is a cyber security life model. So we always have to start from the prevention. So you know that prevention is better than cure. So same thing apply for the cyber security in a electrical power system. First you have to prevent the attack, or otherwise the attack is not prevented, we have to go further. The second one is called as a detecting any cyber attack happened or not. So if there is any cyber attack detected, we have to go for the third step is called as a mitigation. So mitigation is usually done by, we have to be island the power systems. So the fourth one is resilient. You have to be strengthen the resilience of the power system, and then we have to make a forensic analysis where it has happened, who created the attack, and last one deterrence. We try to be make the attacker too difficult to attack our systems. So that is called as a deterrence. So after that, again it go back to the preventing of the cyber attack. So this is a general cyber security life cycle model for the electrical power systems. So taxonomy of CPS. So I am summarizing the taxonomy of CPS given in the paper. So the number indicates the types of cyber attacks. 63 cyber attack types and 38 detection methods of the cyber attack detection method, and 23 mitigation methods, and 8 types of risk analysis, 10 types of threat modeling, and 14 types of vulnerability assessment. So on the right side, I have given my paper, Cyber Physical Power System, a review on modeling, simulation, and analysis with the cyber security application. So the reader, the viewers, if you are interested, please visit the paper. It is freely available and online. IEEE, there is no need for IEEE membership. So just to put the title in the Google, you can download the PDF and you can go through the basics of cyber security in an electrical power system. It is a useful paper to all the basic to the high-end researchers. So research area. So what are the research area? I will directly go to the research areas. So the research areas are focused on modeling and analysis. So modeling and analysis in cyber physical power system is one of the hard domain in CPS. CPPS simulation. So combining the cyber and the power simulation, that is called the cyber simulation. Contingency analysis, that is cyber attack, and then the fourth one, cyber security. So if you are you are interested in this domain, so please send a mail to me. So always I will available for to help you in this research domain areas. We have the team in cyber physical power systems. You are always welcome to join our team. So the conclusion, so CPS is a new technology. We already adopted this CPS in CPPS. The main objective is to achieve the high efficiency and the performance of electrical power systems. And second point, research studies on modeling simulation has gained attention in the current researchers. So researchers are very much interested to modeling and simulation of this cyber physical power system. There are a lot of softwares are available, specifically MATLAB and Big Silent Power Factory. And then another one is emergence of CPS. So it will makes our power system more efficient and highly operational one. And fourth one is the research area in CPPS is exponentially growing year by year. So I hope everyone have interested with this, and I hope you enjoyed the presentation. So these are my publications in related to the area of cyber physical power systems. So and then 3 patents have granted for electrical power systems, and then my last patent in cyber physical power system area. So thank you for your attention. Thank you.
So thank you so much, sir, for your excellent presentation on cyber and power systems. We have learned 2 different areas mingling in your same system, sir. And congratulations on your patent for power systems, sir, which is a very rare one, seriously, from the coordinator side. Congratulations.
Yes, thank you, Sankaran.
Thank you, sir.
Thank you, Raja Vikram. Very nice.
Thank you, sir. Thank you, sir. Thank you very much, sir.
We'll meet you tomorrow, sir, for another session.
Okay. Thank you, Sankaran. Okay, thank you.
Tangasan, recording off பண்ணிருங்க.
Yeah, I'll do it, sir. I'll do it.
So next session will start automatically. The speaker will continue.